Welcome back to Smith Coding Design. This is the third tutorial for our microARC Vise fixture plate. And so what I've done here is I've went ahead and set up ahead of time a 2D pocketing toolpath, which we will delete. And so if you watch the overview video, you'll know that I mentioned that I was not a fan of the surface finish I was getting using just a standard pocketing toolpath. And so I wanted to explain what was happening and why I didn't like it. So if we look at the toolpath, you'll notice as the machine sort of walks around the outside contour of our part and works its way in, there are these spots where there is a rapid change in direction. And so the machine has momentum. The Tormach cannot transition instantaneously. So when it gets to these changes in direction, it dwells there, and you'll see a swirly tool mark. And so I was not a fan of that, which is why I decided to move away from the pocketing toolpath for the top of this part. And so instead what I discovered was a 3D flat toolpath. So we'll go ahead and make our 3D flat. It's the first time I've used this toolpath, so I'll kind of walk my way through it. And we'll examine the surface finish and we'll see why I liked it better than I did the pocketing toolpath. So let's go ahead and just delete the pocket. And now we'll go ahead and create our 3D flat. So we'll just go up here to 3D and we'll just sort of hover over 3D flat. And with all of the 3D toolpaths, Fusion 360 takes our geometry into consideration. So it's going to find all the flat areas in our part and finish them for us. So what we're going to do is go ahead and select the toolpath. And then again, we're going to select the same 3/8 inch 3-flute Gorilla Silverback end mill. We'll select OK. We're running at 7,500 RPM since we're finishing. I'm going to leave it at 30 inches per minute. There's only 10 thou on the floor, so we could go much faster if we wanted. Again, finishing, so I'm going to go nice and slow. In terms of geometry, so normally because it's a 3D toolpath, and again, repeating myself here, but Fusion 360 takes the geometry into consideration for us, I would typically skip this tab, but what I want to do is I want to enable avoid touch surfaces. And I want to make sure that we do not touch the pins. So we'll create a separate 2D contour toolpath, and we will enable the wear compensation. That way, after we machine around the pins, if it doesn't fit, we can go ahead and enter a negative tool diameter in Path Pilot and just rerun that toolpath again and walk around the pins until they do fit. Okay, so we have the pin selected, and I'm also just going to go ahead and select the sidewall here. Okay, so now we have the surfaces that we don't want to touch. We'll go ahead and go to our heights tab, and for our top height, again, we've already removed all the material off the top, so we are just going to select model top. Then we'll go into our passes tab where things get more interesting. So again, I want to avoid a pocketing type strategy, and instead what I would like to do is a parallel. So as you'll see here in a minute, it gives us a more uniform toolpath, so sort of like a facing operation. And to me, it just looked more visually pleasing. So I'm going to go ahead and select that. For the step over, again, I'm going to use 50% diameter of the tool. And then I am going to select machine over holes. You see a bunch of holes that we will drill here in a minute. So what I want to do, if we hover over machine over holes, it literally does that. It machines over the holes instead of avoiding them. So I'm going to select that. And the next thing I want to do is I do want to go to stock to leave. And so I don't want to leave any stock on the floor, but I do again want to leave at least 10 thousandths on these pins so that if we need to, we can walk them into tolerance. So I'm just going to go ahead and leave 10 thousandths on the sidewalls, and I'm going to leave nothing on the floor. I'll go ahead and enable smoothing and feed optimization, and that should do it for this toolpath. So we're going to go ahead and click OK. Give Fusion a minute to generate it, and now again we'll just go ahead and right click and simulate, and we'll just sort of look at what happened. Slow it down a hair So there we go. And so you'll notice again, it's sort of like a facing operation where we're just going left to right, and it's a more uniform surface finish, and we don't leave those tool marks all the way down the part going toward the center. All right, so what I'll do now is I'll just go ahead and speed it up a little bit so we can get through it. Again, it's avoiding the pins. It will go through here in a minute and just clean up that excess stock, but it does avoid the surfaces we told it not to touch. There we go. So we'll go ahead and exit. So that does it for the 2D flat. So I hope you guys enjoy that. So what I'm going to do now is go ahead and create the 2D contour. So we will go up to 2D, again, contour. And then what I'm going to do is, of course, select the same 3/8 inch Gorilla Silverback 3 flute. Select OK for finishing. So I'm OK with leaving it at 30 inches per minute, 7,500 RPM, little over 1 thou per tooth. Going to go to geometry, and all we're doing here is finishing the pins and this sidewall here next to the flat. We'll go into our heights again, model top. We've already faced all the material off the top of our model. And now we'll go into passes. And what I want to do here is I want to enable stock to leave. And so what I want to do is avoid touching the floor that I've already finished. So we're going to leave no radial stock on the sidewalls, but we will leave 1 thou on the floor just to not touch the surface that we finished. The next thing I want to do is change the compensation type again to wear. That way we can enter a negative tool diameter in Path Pilot. So if for some reason after we machine the pins they're too big, we can just walk them into tolerance. You can actually right click on the G code in Path Pilot and say start here, so we don't have to do all of the operations again. We can just come back to this single 2D contour toolpath. Okay, so that looks good. I'll go ahead and enable smoothing and feed optimization. Everything there looks good. I guess we can add in just 50 thousandths of finish overlap. And I always change my lead-in sweep angle to 45 degrees by habit, so I'm going to do that. All right, we're going to select OK. And there we go. We finished our pins, and we've sort of finished the wall here next to the flat. So we'll just, as always, simulate. Slow it down just a hair so we can see what's going on. There we go. Just walking nicely around those pins and then coming down and finishing the sidewall. So now what we'll do is we'll start getting into the drilling operations, which should go rather quick. So we'll go back here to our home view. And the first thing that we want to do is go to drilling. And what we want to do is just go ahead and spot drill all of our holes. So I'm going to select a tool, go to my Tormach 770 library, and I want the 1/4 inch spot drill. It's 140 degrees to match the drill point angle on all of my carbide drills. So we're going to go ahead and select that, select OK. Everything here is fine, running at 5,000 RPM, and we're just plunging at 13 inches per minute. So what I'm going to do now is go to geometry, and we're just going to select all of the holes. All right, so that looks good. The next thing I want to do, and we could have selected same diameter if we wanted, but I just clicked on all the holes. It was rather easy. So we'll go to our heights, and now we want to be careful here. We don't want to go to tool bottom. So if we tried to plunge that spot drill all the way into the bottom of the hole, we are going to crash our machine, ruin our part, and break the spot drill. So what I want to do is I want my top height to be the top of the hole, right? That's fine. And then I want my bottom height to be the top of the hole, and I'm going to go down 45 thousandths just to get the top of, just to get the drill point in the top of the hole. And so I need a point there. So that should be good. So now we're just going to drill in and rapid retract and make all of our spots. Yep, drilling with a rapid out, so that's fine. Again, we'll let Fusion generate the tool path and we will go ahead and simulate. Go ahead and press play. So there we go. We just simply went through and spotted all of the tools, nothing major here. So now what we want to do is we want to go ahead and do our deep drilling cycle where we go ahead and peck all the way through the part. So we'll do that now. So I am going to go to drilling again, and this time we are going to go to the Tormach library that I set up and choose the 1/4 inch drill. And again, this time we were at 4,000 RPM and we're plunging in at 15 inches per minute. I'm going to go ahead and again just sort of click all of the holes. So to save time, I could have duplicated the spot drilling toolpath and then changed the tool and changed the drilling operation, and it would have left the geometry selected for us. So that's something I could have done to save time, but there's not a lot of holes, so it was easy to just go ahead and make a separate toolpath. All right, everything here looks fine. What I'm going to do now is go to heights. Now here, the only thing I want to do, so we do want to drill from the top of the hole to the bottom of the hole, except I want to drill the tip of the hole through the bottom, and I'm going to go an extra 50 thousandths just to make sure that we break all the way through the hole. So if I hover over this, it should explain. So we're just making sure that we go 50 thousandths past our drill point. That way we go all the way through and we have a nice exit in terms of our hole. So when we go through on the backside and do the chamfer, we won't have to worry about there being any large pieces of stock or anything like that left over. All right, so now we'll go to cycle, and what we want to do here is we want to go deep drilling with full retract. Pecking depth, I am going to change that to 30 thousandths. Okay, so that should do it. So we'll just go ahead and click OK, and then again we'll simulate. And what I do like to do with the drilling is I like to use flood coolant just to make sure, especially, I mean, I'm drilling right around an inch. So I'm going an inch deep essentially into this material, and I want to make sure that I have decent chip evacuation. So I tend to use flood coolant when I am drilling rather than using the fog buster. So we'll just go ahead and simulate. And so what we're doing is just going through and pecking our way all the way through. So we'll go ahead and speed it up a little bit. There we go. And so the next thing we want to do is we want to go ahead and clear out the countersink here. So we'll just use a pocketing operation to do that so that our socket head cap screws will go ahead and fit all the way inside flush with the top surface of our part. So we'll go ahead and exit simulation. We'll go back to our home view. All right, so now we'll go ahead and go to 2D Pocket. We'll go to our tool library, to my 770 library. We're going to select the 1/8 inch 3-flute end mill from Shard Tools. We're going to run at 8,000 RPM, but we're going to drop the feed rate slightly and go 25 inches per minute. So we're going to be conservative, and I'll show you why in a minute. We're going to go to the geometry page, and I'm just going to orbit so I can see the inside of our mounting holes. So what we're essentially doing here is we're going ahead and clearing the countersink for our M6 socket head screws. So the socket head screws should mount inside of our holes and go just a little below the surface here. That way there isn't any interference with our vise. And we're being conservative because we're going to plunge all the way down, full depth of cut, and then work our way through the pocketing operation. And so now we'll go to heights, we'll reset our view so we can see. And again, we want to use model top, not stock top. There we go. We will go into passes. We're going to have our maximum step over at 15 thousandths. Again, we're being conservative because I don't want to break my 1/8 inch end mill. I've already went through 2 of them in the past week. All right, so the next thing we're going to do is enable the finishing passes, and we want that to be 10 thousandths. And what we're going to do here is just go ahead and we'll do a 50 thousandths finishing overlap. All right, that's fine. No stock to leave, no multiple depths. I will enable smoothing and feed optimization. So the next important thing that we need to do is we need to go to linking. And since we already pre-drilled these holes, we don't want to do a ramp or helical entry. What we want to do to save ourselves time is go down to where it says position, and then we'll click select under pre-drill position, and then we will select the holes that have already been pre-drilled. And so the tool should go ahead and plunge into the center of the circles and then work its way through the tool path. That way, again, we don't have to do a ramp or a helical entry. So we'll go ahead and press OK. And then we will simulate to make sure that that is the case. So I'm going to right click, I'm going to go to simulate, and then I'm just going to go ahead and use the timeline here. And what I want to make sure of is I want to make sure the tool holder doesn't contact the surface of the part. I've done that before, it's not fun. And I want to make sure that as we're plunging down, we're plunging into the center of the hole and not directly into our stock. I've done that before too, and trust me, it's not pretty. So we want to avoid those sort of crashes. And everything looks fine. And then we just work our way through the pocket, clearing a path for our M6 screws. All right, we'll go back to our home view, and then we'll just go ahead and finish walking our way through the tool path. So everything looks good there. So now all we need to do is go ahead and finish our Op1 by chamfering all the edges, making sure there's nothing sharp that could cut someone's finger, and to make sure that everything's nice and smooth, there are no burrs. So we'll go ahead and do that now. So I'm going to go ahead and go to 2D chamfer. Okay, and now what I'm going to do is select a 1/4 inch chamfer tool from Gorilla Tools. So I will go ahead and do that. Our lemur chamfer. So we'll select that tool. We're running at 4,000 RPM and 20 inches a minute. Again, we could push the feed rate up if we wanted. I'm not going to. We're right at around 1 thou per tooth. For geometry, we are going to finish essentially all of our edges around the holes, around the outside of the part, along our flat. And we're also going to chamfer the top of the pins. Okay, so that should do it there. The next thing we'll do is go to our heights. Again, model top instead of stock top. Selected contour for the bottom height is perfect. We'll now go into passes, and I'm going to do a 10 thou chamfer. Chamfer tip offset is fine. Enable smoothing and feed optimization, and that should be everything. We'll change the lead-in sweep angle to 45 degrees. And we will go ahead and generate the tool path. Now we'll simulate to make sure we don't crash our machine. There we go. So we just start walking around the pins. So we'll go ahead and speed it up a little bit. Then we chamfer all of the holes and then the outside of the part. And I imagine here in a second, and we'll do the bottom of the flat. There we go. So that's it for the chamfer. So that's it for Op1. I hope you enjoyed. What we'll do now is we'll go ahead and look at the tool paths or the operations being performed on the Tormach. So I hope you enjoy, and I'll see you in the next tutorial where we will start getting into Op2. Alright, so now we start with the 3D flat toolpath using a 3/8 inch 3-flute Gorilla Silverback end mill, running 30 inches per minute, 10 thou depth of cut, and 50% diameter of the tool for width of cut. I like this toolpath because it gives you the option to use parallel, which gives you a nice uniform surface finish that is similar to a facing operation. So leave me comments, let me know what you think about the toolpath, or if you've used it before. Bear with me here, the toolpath is lengthy, but I wanted to provide footage that sort of shows both sides of the part being faced with the 3D flat. Again, if you use the toolpath, let me know in the like and comments. If you have any tips or tricks, go ahead and leave those posted for the community as well. Thanks. So you may also noted I did go ahead and upgrade all of my end mills to have a coating. I figured since for filming purposes I'm using the fog buster mostly instead of the flood coolant, I might as well go ahead and get coated end mills just to help with the lubricity and to prevent any chips from sticking to the end mill. I don't want to end up with any sort of chip welding or anything like that that would degrade the performance or damage the end mill. So now we jump into the 2D contour using the same end mill, 30 inches per minute, full depth of cut, which is 1/8 of an inch for the pins and 1/4 of an inch for the sidewall on the flat. Again, we are just walking around the pins, making sure we get them in tolerance. We have the wear compensation enabled, so if we need to go back and change the tool diameter in PathPilot and walk in the tolerances of our pins, we can do that. So that's it for the 2D contour. Now we get into our drilling operations. We do the spot drill with the carbide spot drill from Shard Tools. We're running at 13 inches per minute, and we're just going down 45 thousandths. The spot drill has the same tip angle as the carbide drill we'll use next, which is right here. Again, this is a deep drilling cycle with full retract. I'm using a 1/4 inch Kinmetal Go drill, 15 inches per minute with a 30 thousandths peck. I do have my flood coolant enabled here simply because it gives me superior chip evacuation, which I tend to prefer, especially if I'm doing deep drilling. I use green cut coolant just because it has the safest materials safety data sheet I could find. I didn't want anything that could potentially harm me or the environment, especially if you have any leaks in your Tormach. You don't want that all over the garage if you have animals or small children around. So now we're going to go ahead and clear the way for our M6 socket head screws. We're using a 1/8 inch Shars 3-flute end mill, 25 inches per minute, a 1/4 inch depth of cut, and 15 thousandths width of cut. And again, we're just going through and clearing the countersink so we can install our socket head cap screws and mount the fixture plate to the microARC, which you see there on the left. And there's some clearance, so I believe the socket head cap screws will fit around 20 thousandths below the surface of the part. And now we're going to go ahead and finish off Op1 with a chamfer. We're using the 1/4 inch Gorilla Lemur chamfer, 20 inches per minute, and our chamfer width is going to be 10 thousandths. So right now we're just walking around the top of the pins. We'll also chamfer all the holes, and then we'll chamfer the contours around the outside of the part, and then the contour on the flat. So that does it for this tutorial. I hope you enjoyed. Please tune in for the next tutorial where we begin Op2. That will be posted shortly.